Okay, this is another application of sum and product roots. Okay, so in this question, we were asked to find the quadratic equation, okay, with the roots that are the square of the roots of this. Okay, so that means what I need to do, step 1, is I need to figure out what is roots of 2x squared plus 3x plus 5. Now, some of you girls will take one look at this and say, hey, the discriminant of this is less than 0. Okay, because the discriminant is b squared minus 4ac, so 3 squared is 9. 9 minus 4 times by 10, 9 minus 40 is definitely a negative number. So if the discriminant is less than 0, you will say, hey, there is no roots. Okay, you are absolutely right, except that there are roots, but it's just that there are no real roots. Okay, there are no real roots. So in terms of plotting a graph and everything, yeah, there's no real root, so it doesn't touch the x-axis. However, there are complex roots. Complex roots do exist. Okay, so for those of you girls who's going to go into extension 2, you will come across the complex roots later. All right, but for the purpose of extension 1, let's not look into the complex roots. Just remember, even if the discriminant is less than 0, we ignore it. Okay, we ignore it. So don't worry about this. But don't worry about this. This is not part of the question. Okay, don't worry about this. So we're going to look at this and we're still going to solve it as it is. Okay, so the square of the roots of this. So first of all, I need to figure out what the roots of this is. So I know that this is quadratic. So we've got two roots, alpha and beta. And I know that sum of these two will be negative b over a. And then I know the product of this is d over a. I know that. Now, what I'm going to do is now we're going to look for the quadratic equation where the roots is the square of these things. So in another word, for this quadratic equation, its roots are the square of these, so alpha squared and beta squared. I want an equation where the roots are alpha squared and beta squared. So I need to use my algebra to figure out how the connection between alpha squared, beta squared, and alpha plus beta. Well, I know for a fact that alpha squared plus beta squared, which is the sum of roots for the quadratic I want, is the same as alpha plus beta, the whole thing squared, minus 2 alpha beta. Okay, if you're not quite sure why this is, you can do a little exercise and expand alpha beta squared and see what you get. Okay, I'll leave that to you. Now, once you've done this, now I can say, okay, well, that from this point onward is just a matter of substitution. This is negative 3 over 2 to the power of 2. Take away 2 times by alpha beta is 5 on 2, which gives you 9 on 4. Take away 5, which gives you 2 and a quarter, minus 5, which gives you negative 2 and 3/4. Okay, so that is alpha plus beta. That is also negative b on a for the quadratic I want. All right. Now, alpha beta, so that's one of them. So the second one would be the product roots for the quadratic I want. The product roots will be alpha squared times by beta squared. Now this one, okay, this one is the same as alpha beta, the whole thing squared, which would give you 5 on 2, the whole thing squared, which is 25 on 4. That would give you the value of c on a. So from here, what is the quadratic I'm looking for? I'm looking for, remember the quadratic is, ax squared plus bx plus c. And if you, I'm just doing this again, okay, for you. So some of you girls, this might become very, very, like, you don't have to do this step, okay? You can go directly into the final step and tell me, oh yeah, well, that if negative b on a is this, that means b on a is the negative of it, so the equation must be x squared plus 2 3/4 of x, and c on a is right here, plus c on a, which is 5 over 4. That is the quadratic with the roots that are the square of the roots for this quadratic.